Welcome to 5th grade Unit 1, Addition and Subtraction with Fractions. Have your note sheet ready and your notebook. Be prepared to take lots of good notes. Here we go. The first topic we're going to talk about is equivalent fractions. Equivalent fractions mean that whatever we do to the fraction, it's still in the same proportion. So if we cut an object into more slices or pieces, we still would end up with the same amount of it. So in this case, we had 2/3. If we multiply 2 to the top, we would have to do the same to the bottom. What we do to the top, we have to do to the bottom. That's going to keep it proportional. So if we look at our example over here, we can write 3 more equivalent fractions to this. And we can think about any type of number we want. So we could do times 2. 3 times 2 is 6. What we do to the top, we do to the bottom. 5 times 2 is 10. So 6/10 is equivalent to 3/5. We could multiply it by something bigger, maybe 9. 3 times 9 is 27. And 5 times 9 is 45. 27/45 is equivalent as 3/5. We could multiply it by 10 and say it's 30/50. Again, whatever we multiply, as long as we do the same to the top and the bottom, we would end up with equivalent fractions. Equivalent has the first starting part of the word of equal. Equivalent means the same thing as equal. Next concept, mixed numbers. If we want to make a mixed number a fraction, we're going to make it mixed and we're going to turn it into improper. So let's really dive deep into what this number means. 3 whole means that I have 3 pieces of these 4 broken into 4, but I have the entire amount of them. So what I really have is 4/4, 4/4, and 4/4 3 different times. So the true amount that I would have is 12/4 for this 3 whole. So if I want to convert it, what I can do is the big number times the bottom number, because I'm multiplying how many parts I had. So 3 times 4 is 12. And then I'm going to add how many pieces I have still on top. So I'm going to add that 1. So 3 times 4 is 12, plus the 1 gets me the 13 on top, and the bottom stays the same. I like to use the little rhyme, big times bottom plus top is top, bottom stays the same. Big times bottom plus top is top, bottom stays the same. Changing from an improper fraction to a mixed number just uses division. A fraction symbol really is just division, a division bar. So the top number for division, that's right where we can see it, is on the inside. The bottom number is on the outside if we were going to divide this number out. So the 13 goes on the inside, the 4 goes on the outside. 4 goes into 13 3 whole times with 1 left over. The leftover is our numerator, and what we divided by the 4 is our denominator. The next thing we're going to need to know about, and this is not in your notes, none of those last 2 slides were either, so you're going to want to pay attention to this. The LCM stands for the least common multiple. Let's get my pen working back again. Least common multiple. So a multiple is when we do our count bys of numbers. So if I had a 9 and I had a 12, I would do count by 9s, 9, 18, 27, 36, 45. And I would do my count by 12s, 12, 24, 36, 48. The least or smallest number that they both have in common or share is 36. Now, where this is important is when we're trying to make fractions have the same denominator, bottom number. We want to use the LCM. So that's going to come into play here when we are comparing fractions or if we're adding or subtracting fractions in this unit. So right now, if I take a look at these two fractions, I have one broken into 6 parts and I have one broken into 9 parts. That is not going to work extremely well for me. So first I could convert this one to a mixed number. I have 1 and I have 3/6. Now that maybe would have helped me out, but coming up with a common denominator would be more helpful. So I'm going to find the LCM between 6 and 9. We have 6. We have, not 9, I was going by 3s there, 12. We have 18. Oh, I can stop right there already because I know that we have 9 and then we have 18. So 18 is my LCM, my least common multiple. So how do I get to 18 with 6? I multiply it by 3. What I do to the bottom, I do to the top. So in this one, I end up with 1 and 9/18. And on the other side, I multiply the 9 by 2. What I do to the bottom, I do to the top. So I end up with 1 and 4/18. So now I can compare these because they have the same denominator. I have 9/18, I have 4/18, so I know that 9/18 is bigger. The same process goes when we're adding fractions. I cannot add these fractions together right now. I need to come up with a common denominator. So, what is common between 6 and 8? I can start doing my count bys. And I'm going to count by the larger number, 8. Can 6 become 8? No. The next one's 16. 6 cannot be 16. The next one's 24. Yes. So my least common multiple is 24. I get this one by multiplying it by 4. And I get this one by multiplying it by 3. By coming up with the least common multiple, we are going to have a more simplified answer than if we just used any other numbers that they have in common. So I'm now going to rewrite my problem. I have 1 and 16/24. And I have 9 and 9/24. Now I can add them together. 9 plus 16 is 25/24. Well, I know that means I have one more whole number. So I'm going to take that one out, and I'm left with 1 out of 24 pieces. And now I add. 1 plus 1 plus 9 is 11. So my answer would be 11 and 1/24. But I could not just add these fractions together because they had a different denominator. We have to come up with a common denominator before we can add them. On to our next one is subtracting fractions. Again, same thing. We need to come up with a common denominator first. So if I look at 6 and I look at 4, I can start doing my count bys. Can 4 become 6? No. The next count by is 12. Can 4 become 12? Yes. So we're going to times this by 2. And what we do to the bottom, we do to the top. And down here, to make it to 12, we multiply by 3. So we're going to do that to the top. This problem now is 9 and 10/12 minus 4 and 3/12. If my top is bigger than my bottom fraction, I can subtract, which it is. 10 minus 3 is 7/12. If my top was not bigger, I would have had to borrow a whole. And remember, when we borrow a whole, we add how many pieces our whole had to the top amount. But now we can do our whole numbers. 9 minus 4 is 5, so we get an answer of 5 and 7/12. Try the practice problems on your sheet. Resume the video to see how to solve each of these problems. All right, mark all fractions that are equivalent to 2/3. A, because we can multiply the top and bottom by 2. D, because we can multiply the top and bottom by 6. And E, because we can multiply the top and bottom by 5. The other 3 fractions would not be equivalent because we cannot multiply or divide the top and the bottom by a same number. For the next part, we're going to place the fractions on a number line below. In order to do this, we might have to convert our fractions into decimals. In order to do that, we divide. Again, you place your top number on the inside, your bottom number on the outside. You might have to add decimals and keep going. So 3/8. I did not know what 3/8 is as a decimal. So I put the 3 on the inside, the 8 on the outside, and I started to divide out. 8 went into 3 0 times, so I can add a decimal and keep adding zeros. So now 8 goes into 30 3 times. And then 8 goes into 60 7 times with 4 left over. And then 8 goes into 40 5 times. So 0.375. So I'm going to put my A between the 0.25 and the 0.5. My B is going to be past the 1 whole, and I'm going to go to 0.5 because a half is 0.5. For C, I might simplify that fraction first, and I could divide the 6 and the 24 both by 6 to get 1/4. And I know that 1/4 is the same as a quarter, so that's 0.25, so C goes there. And then again, for number D, I can simplify my fraction, so I would have had 1 whole and 1/4. And again, I know 1/4 is 0.25, so 1.25, and I would put my D there. Entering equivalent mixed numbers for each fractions. How many 4s go into 15? It's 3, with 3 left over out of 4, so 3 3/4. How many 3s go into 28? It's 9, with 1 out of 3 left over, so 9 and 1 3/4. 9 and 1/3. Our next problems, we needed to find a common denominator for our addition problem. And if we looked at the bigger number, 6, yes, 2 could become 6 by multiplying it by 3. So we did that and got 3/6. 3/6 plus 1/6 is 4/6. And then we add our whole number and we get 3. But we can simplify. 4/6 can be divided by 2 on the top and bottom, so we get 3 2/3 is the best answer. For our subtraction problem, we needed to find a common denominator. What's common between 5 and 4? It is 20. So we multiplied the top fractions by 4 to get 8/20. We multiplied the bottom fractions by 5 to get 5/20. And then we can subtract. 8 minus 5 is 3/20, and 6 minus 5 is 1 whole. This next problem looked more tricky than it really is. If Kate pours 4/5, the 4/5 is going to go on top, and poured another 9/10. 9/10 is going to go on the bottom, and we're going to add them. Now this next set shows the equal signs. So I need to find a common denominator between 5 and 10. So the common denominator is 10. So we multiplied the top fraction here by 2. So 4 times 2 is 8. 5 times 2 is 10. And we could keep the 9/10 fraction the same. When I add these together, 8 plus 9 is 17 over 10. I then need to convert that into a mixed number. 10 goes into 17 one whole time, with 1 out of 10 remaining. Practice on your IXL skills plan for grade 5, unit 1, or Math Activity Center in Math Expressions. Do some of the lesson checks. The one that I would really focus on would be any of the subtracting fractions with unlike denominators. That's the big new skill for this unit. Rewatch the video if you need to. Otherwise, good luck.